All right, so today we are going to be talking about exponential growth and decay functions. So an exponential function is a function that's in the form y equals a times b to the x power. Or, of course, you could also have f of x is equal to a times b to the x power. Either one of those would be acceptable. A cannot equal 0, and b is a positive number that's not equal to 1. Oops. Because if you raise 1 to a power, what's 1 to any power? It's still 1, right? So, so you're not going to get an exponential function in that case. All right, so when we're talking about exponential growth, for a growth function, that means my base is greater than 1. And so the graph rises as we go left to right. And if it's exponential decay, that means that b is between 0 and 1. So it's a fraction or a decimal. And then the graph would fall as you go left to right. And looks something like that. So with an exponential function, we have either a growth or decay factor, depending on which type of function it is. And that's just the base, b. That's your growth or decay factor. And then finally, an asymptote is a line that the graph gets closer and closer to, but never quite reaches it. So let's look at the parent graph for an exponential growth function first. It's growth. That means that my base has to be greater than 1. So right now, the parent graph, we don't have an a out in front of it. We just got b to the x power. And so if I were to graph it, if I put in a 0 for x, that means y is equal to b to the 0 power. What's anything to the 0 power? 1. And then if I put in a 1, that means y is equal to b to the first power. That's just b. So the 0.01 is on there, and then 1b, and I'll just pick a random b right there. And the graph, as it goes to negative infinity, is going to be approaching 0. It just never quite gets there. So let's see here, we've got the 0.1b is on the graph, and the 0.01 is on the graph. So that means I have an asymptote because it's never quite getting to 0. The asymptote for this one is the x-axis, or the line y equals 0. And for my domain and range, okay, so I can see that it's going infinitely to negative infinity and infinitely to positive infinity. So is there any limitation on what I'm going to have put into my function? Can I put in any kind of number for an exponent? Can it be negative? Can I have negative exponents? Yeah. Could I have positive exponents? Yeah. Could I have fractional exponents? Yeah. So it's all real numbers for the domain. There's no limitation on what I put in to the function. However, there is a limitation on the output, because if you look at your y values, is it ever going to reach 0? No, it's just getting closer and closer and closer. So y is always going to be greater than 0 for the parent graph. Any questions? All right, so let's take a look at an example with a specific number this time. 2 for my base. So I'm going to graph y equals 2 to the x power. So I can make myself a quick little table. If I plug in -2 for x, I have 2 to the -2, so that means I flip it over, right? 1 over 2 squared, so that's 1/4. And then if I plug in a -1 for x, I have 2 to the -1, which is 1/2. Then I have 2 to the 0. Anything to the 0 power is 1. Then I would have 2 to the first, which is 2, and 2 squared, which is 4. So I can use those points then to draw my graph. So when you get to the fractions, you just kind of approximate it as best you can. It's not going to be perfect, but that's okay. Okay, and then we would just draw a curve through those points. And again, it's just approaching 0. It's never going to quite cross it. So we have an asymptote of y equals 0. And my domain and range is still the same thing. My domain is all real numbers. And my range is that y is greater than 0. Okay, so when you're done copying that down, I'm going to let you guys do this one on your own. All right, so if I put in a -1 for x, what am I going to get for y, Alexander? That would be for a -2. If it's -1, it's just going to be, yeah, it would just be 1 over 5. Okay. Anna, what about when I put in a 0? Ella, what about if I put in a 1? And if I put in a 2, Zach? 25. So that one's not going to fit on this graph. All right, so -1, 1/5. Again, I just do the best I can to approximate fraction. And 0, 1, 1, 5. And then the other one's way the heck up here somewhere. So it looks basically the same. It's just a little bit steeper than the previous one. Okay. Anybody have any issues with that? Any questions? All right. Okay, so let's take a look at a decay function now. So now my b value is between 0 and 1. So those same 2 points are on the graph when we did it like generically. If I plug in a 0, it's 1. If I plug in a 1, it's b. It's just this time b is between 0 and 1. So when I go to graph it, it's somewhere between those 2 points, and then we'd have. So the graph starts out really high and comes down and approaches 0 again. So I still have an asymptote of y equals 0, or the x-axis. And just like before, there's no limitation on my domain. I can put any kind of exponent in, so it's all real numbers. What do you guys think about the range? It's still greater than 0, yeah. Y is greater than 0. Because it's above the x-axis, right? Y is always going to be positive in this case. And it's never going to quite get to 0. It's just going to be approaching 0 as we go towards negative infinity. So let's take a look at an example. We've got y is equal to 1/2 to the x power. So I'll go ahead and make myself a table. Okay, and there's nothing magic about the numbers that I'm picking. I'm just picking numbers that are going to give me something manageable to graph. I could put anything in a table, but I want it to be something that's going to be somewhere near the origin, so that's why I choose the numbers I choose. Okay, so if I take 1/2 to the negative 2 power, what's that mean? Yes, it equals 4, because I have to flip it over and square it. And if I take 1/2 to the negative 1 power, I get 2. To the 0 power is 1. To the first power is 1/2. To the second power is 1/4. So you can see it ends up being starting off with a higher number and then slowly getting smaller. So the graph would look something like that. I still have an asymptote. That's the line y equals 0. My domain is still all real numbers, and my range is y is greater than 0. All right, so sometimes we have something out in front of our base that we're multiplying by, our a times b to the x. And so what the a does is it either vertically stretches or shrinks the graph. Just like when we had parabolas and everything else. Okay, it stretches it when the absolute value of a is greater than 1. And it shrinks it if the absolute value of a is between 0 and 1. So if a is negative, what do you think is going to happen? What happened before when we had a negative a? Like with a parabola or absolute value, go ahead. It flips it over, right? It reflects it across the x-axis. Okay. So let's take a look here at example 3. We're going to graph y equals 1/2 times 4 to the x power. So the first thing I'm wondering, is this a growth or decay function? If you think it's a growth, hold up one finger. If you think it's a decay, hold up 2 fingers. So growth or decay, show me what you think. Okay, which part determines if it's growth or decay, the A or the B? The B. The B determines it. Remember, if the base is more than 1, then it is growth, yes. So this one is a growth function. All right, so I'll just make myself a little table here and we'll graph it. So let's see here. I'll go ahead and do -2, -1, 0, 1, and 2. All right, so if I put in a -2, I've got 1/2 times 4 to the -2 power. That's going to be a pretty small fraction. I don't think I want to be graphing that one because that's 1/2 is 1/16. So I don't think I'm going to fit that one on my graph. That's going to be pretty hard to differentiate. Then if I do the next one, I've got 1/2 times 4 to the -1, so that's times 1/4. And then if I do 0, it's 1/2 times 4 to the 0, which is 1. So that's 1/2. And then then I'll have 1/2 times 4, which is 2, and 1/2 times 16, which is 8. So yeah, I'm not even going to try and graph 1/32. 0, 1/2, 1, 2, and 2, 8. And then you just do your best to fit a curve to those points. So you'll see on all of these today, because we haven't moved our graph, translated it all, the asymptote is always coming out to the line y equals 0. That will change though if we translate the graph. We'll be talking about translated graphs tomorrow. So, so the other thing remains the same also. The domain is still going to be all real numbers, and the range is that y is greater than 0. So the next example we're going to do is y is equal to -3 times 2/5 to the x power. Okay, so again, now show me on your fingers, do you think it's growth or decay? This time, growth or decay? Yeah, it's decay. Because now my base is between 0 and 1. It's only 2/5. So if I make myself a little table here, do -1, 0, 1, 2. Okay. All right, so if I plug in a -1, that means I have to flip it over. And so it'd be -3 times 5 halves. That's -15 halves, which is -7.5. If I plug in a 0, I've got -3 times 1, so -3. If I plug in 1, I've got -3 times 2/5, so that's -6/5, or -1 1/5. And then finally, if I put in a 2, that's -3 times 4 over 25, so -12 over 25. Now, because it has a negative out in front, what's going to happen to this one? It's going to be flipped over, right? It's going to be reflected across the x-axis. So it's going to actually kind of look like it's growing, but it isn't really. It's still technically a decay. It's just a reflection of a decay function. Okay, so let's plot those points. So -1, -7.5, 0, -3, 1, -1 1/5, and 2, -12 over 25. And so it's still approaching 0, but it's still never going to get there. So it's the line y equals 0, or again the x-axis, either way. The domain is all real numbers. But what about our range this time? Now y is less than 0, okay? Because it's all under the x-axis, because it's a reflection. So I have one for you guys. Once you finish writing that down, I'm going to have you guys try this one on your own. Is it going to be growth or decay? Growth or decay? What do you guys think? It is growth. Just because it's a fraction does not mean that it's automatically decay. -7 halves is equal to what?
3.
Or I'm just 7 halves is equal to 3.5, right? That's more than 1. So be careful on that. This one is going to be growth, okay? Is it going to be reflected? Yeah, it is going to be reflected. So go ahead and try that one in your notes. I'll come around and see how you're doing. Just real quickly, I forgot to mention I mean, we already saw this, but on example 3 then, because it has the a equal to 1/2, it's being shrunk by a factor of 1/2, right? And then on example 4, we had a was equal to -3, and so the negative makes it the reflection, and it's being stretched by a factor of 3. So I forgot to mention that when you guys were taking notes on that. All right, so we decided this was growth. And if we put in some points. All right, so if I put in a -1 for x, Anna, what's it going to end up being? -2/7. So we have to flip it over, but there's that negative out in front, so that's still there. Carissa, what if I plug in a 0? -1, yeah. Because again, it's 1, but then we have that negative out in front, so it's becoming negative. Marnie, what about if I put a 1 in? -7/2 or -3.5, yeah. And what if I put in a 2, Melanie? Yeah, -49/4, which I'll go ahead and make into a number so we can mixed number, so we have an idea where it would graph. All right, and so then you would just plot those points, -1, -2/7, approximately there, 0, -1. So is this one being stretched or shrunk? No, it isn't. It's just being reflected because of the negative. And 2 would be somewhere down here. Okay, and so that's what your graph should have ended up looking like. All right, so any questions? We're all good? Okay, that's it for today then.